Okay, in this video we're going to look at terminology for curved mirrors. So there's two main types of spherical mirrors that we deal with in class. The first one is concave, where if you think of the mirror being cut from a circle, so the center of the circle is here, concave means that the reflective surface is on the inside of that sphere. Okay. Convex, again, if it was cut from that same sphere, the reflective surface would actually be on the outside right there. So we have similarities for both mirrors. Whether we're dealing with concave or convex, there's a few terms that are consistent. We have the center of curvature, which is represented by the letter C. That would be the center of the sphere that would have actually made the mirror. So in either case, we have a center of curvature. We have the principal axis, which is the line that goes through the center of the mirror and the center of curvature. And we also have something known as the vertex, and that's the point where that principal axis actually meets the mirror. So these three terms are consistent with both concave or convex mirrors. So here we have a concave mirror. You can see the center of curvature, the principal axis, and the vertex where the principal axis meets the mirror. Now, when we're dealing with concave mirrors, the light rays that travel parallel to the principal axis will be reflected off the mirror toward a single point, and that point is referred to as the focus. So if I actually show you where the focus is, we have to recall from our lab, the focus is actually half the distance between the center of curvature and the mirror. So in our case, we would put the focus right there. So let's look at how these light rays would reflect. So we have our first light ray coming in parallel to that principal axis, and it says that that light ray will be reflected off the mirror and through the focus. So here's another one coming in parallel, and you can see that they're both reflecting through the focus. Now, this is the other reason why concave mirrors are referred to as converging mirrors. Okay, because the light converges to a single point in front of the mirror. Okay, if we look at convex mirrors though, remember light rays in these cases that travel parallel to the principal axis will be reflected off the mirror as if they pass through the focus. And that's because with a convex mirror, the center of curvature and the focus are both located behind the mirror. So what does that statement actually mean? Well, here's our light ray coming in parallel to the principal axis, and we can see that it's going to try to go through the focus, but again, that's behind the mirror. So again, we have our dashed lines. So it really will be reflected off in this direction. Here's another light ray coming in parallel to the principal axis. And again, it's going to try to go through the focus, but because the focus is behind the convex mirror, it will be reflected off this way. So if we look at our two reflected rays, they are moving further and further apart from each other. And we call that diverging apart. So that's the other reason why convex mirrors are referred to as a diverging mirror. So just to review, concave or convex mirrors, we have our center of curvature, which is the center of the sphere that would have been made. We have our principal focus where the light rays are focused or are trying to focus, which is halfway between the center of curvature and the vertex. The vertex is that point where that principal axis meets the center of the mirror. And that's key because it always meets it at a 90-degree angle here. There's two other terms or variables here that I want to point out. There's a big capital R, which stands for the radius of curvature. And if you can imagine that this mirror is made from a sphere, and if C is the center of that sphere, okay, I just want to recap the terms for curved mirrors. Here we have the C, which is the center of the curve that would have made the mirror. F is the principal focus where light rays are focused, and that is halfway between the center of curvature and the mirror. Where the principal axis meets the mirror, we call that the vertex, and the principal axis always hits the vertex at a 90-degree angle. And then we have two other terms. We have big capital R, which stands for radius of curvature. So if you can imagine that this was a circle, okay, the center to the edge of the circle is called the radius. So this is the radius of curvature. That distance from C to the vertex is the radius of curvature. And we have one other distance measurement that we might be talking about, and that's little f. And that's the distance between the principal focus and the vertex, and that's referred to as the focal length. So the focal length is always half of the radius of curvature. So that recaps all the terms for curved mirrors. Now, if the light is coming in this direction, that would be a concave mirror, and C and F would be in front of the mirror. But, let me erase that, if light was coming in the other direction, if light was coming in this direction, then C and F would be behind the mirror, so that would be a convex mirror.